We're going to develop a technique to solve quadratic equations, and this technique is called the square root method. So as an example, suppose I had given you the equation to solve for x squared equals 4. If we think back to when we did factoring, we were able to solve these kind of equations using what was called the zero product theorem. So using the zero product theorem, which we learned in the chapter on factoring, we get a 0 on one side. We subtract 4 and we get x squared minus 4 is 0. And that technique then required us to factor that quadratic polynomial. And this factors as x minus 2, x plus 2 is 0. The whole purpose of the zero product theorem was once you had a product of two binomials equal to 0, either one or the other had to be 0. Working this, we got that x minus 2 would be 0, which would make x2, and here x plus 2 would be 0, which would make x negative 2. This worked nicely, but we can do this in an easier way, which is going to be called the square root method. So we'll start with x squared equals 4. What we're going to do, we have that something squared is 4, so the way we undo a square, the opposite or inverse operation would be square root. So we're going to take the square root of both sides. Square root of x squared gives us x, so x is square root of 4 is 2. But with this square root method, we know we're going to have both a positive and a negative, because that's what we got here. Both a positive and negative when squared would give us 4. So we put plus or minus in front, and that gives us our solutions in a very quick way. And this is called the square root method. We'll try this now. This method allows us now to solve equations that we could not do very easily with the zero product theorem. So for example, I might say solve for x squared equals 12. Using this square root method, I take the square root of both sides, and that gives me square root of x squared is x, and I'm going to get plus or minus radical 12. Now this starts becoming a little bit more complicated, because now what I have to do is simplify square root of 12. And you will recall that with 12 we get the prime factors. 2 goes into that 6, 2 goes into that 3, 3 goes into that 1. And remember, radical 12 is like jail. It takes a pair to jump out. So this becomes plus or minus 2 radical 3. So we get the two solutions for that. We can now extend this method a little further. We can say solve for x. Let's say, suppose I say quantity x plus 3 squared equals 10. This is a perfect setup for the square root method because of the square out front. So I take the square root of both sides. But square root and square undo each other, and I'm left with x plus 3 equals, and the whole key in this method is to write plus or minus and then radical 10. But radical 10 can't be simplified any further. We're almost there. We just have to subtract 3 from both sides, and we get, in this problem, the solution is negative 3 plus or minus radical 10. Now what that means is 1x is negative 3 plus radical 10, which if we needed a decimal we could find. The other x is negative 3 minus radical 10. So two different values, but we put the plus and minus right there. We can go another step further. So for example, I might say solve for x. 2x minus 1 squared equals 18. Now, because we have a square, we're going to undo it with a square root. Square root of square will undo each other. The square root and the square undo each other, and we have 2x minus 1 equals, we always put plus or minus radical 18. But radical 18 can be simplified, and that's the key in these. You have to simplify the radicals. Working on the side, we know 2 goes into 18, 9, 3 goes into 9, 3, 3 goes into 3, 1. So the 3 is going to break out. We get 2x minus 1 is plus or minus 3 broke out radical 2. Now we're going to try and isolate the x, so we would have to add 1 to both sides, which would give us 2x is 1 plus or minus 3 radical 2. Now we're going to divide by 2. So we have to divide the entire term by 2. And that gives us x is 1 plus or minus 3 radical 2 all over 2. So we are going to have two solutions, and we can calculate them separately using the calculator.